Hey. All right, now we're going to be looking at the area model for multiplication. So this says area model. It's section 25 in your book. The favorite problem of mine to introduce the area model with is just 3 times 2. So let's say you have a square. Maybe it's like your flooring of your house that you need to retile. Let's say it has length 2 and width 3. Something that's 3 by 2. And I want to be able to go to the store and buy little 1 by 1 tiles, because this is how area has units, right? So this is how it's united. And now I can have an easy way to see this is to break this into 2. So now I can see that it's 1 and 1. Maybe that line will help remind us that this is in fact length 1, 2. And then this length I'll break into 3. And so now I can see it's 1, 2, 3. And now maybe it's easier to see that that's 6 1 by 1 tiles. So I need 6 square feet or 6 square whatever inches. And I can see that now as 2 groups of 3, or I can see it as 3 groups of 2. Either way. So that's kind of reminding us of rows and columns, the commutativity of multiplication, and just how to see this pictorially. All right, so let's try a number that's harder. Because this is fairly all right, hopefully. So let's do this with a number like, maybe I want to do 12 times 3. 12 times 3. All right. So something that's 3 this way and 12 this way. I could have drawn 12 this way and 3 that way. It doesn't matter, but I'm doing this just because of the shape of my board. All right, so this is 12. Okay. And I'll remind myself and break this into 3. So now 1, 2, 3. Each one represents 1. And now 12. I don't really feel like writing and making 12 boxes. So I might think of a way to write this that's a little bit simple and helpful at the same time. So I'm going to erase this 12, and I'm going to think of it as 10, and then 2 more. So the 10 I'm just going to accept as a unit of 10, and then the 2 I'll actually break that up to truth, right? So now I can say, okay, how much is each bar worth? This is 10 along, and this is 1 wide, because all 1, 2, 3 of them total are length of 3. So this bar is one group of 10, so that's 10. And then this is another group of 10, and this is another group of 10 1 by 1 boxes. And then over here, so that makes 30, and then I can see 1, 2, 3, 4, 5, 6, 36. And then maybe a more trained eye wouldn't even need the lines on the 3, because we're familiar enough with what 2 times 3 is from last time. So when I go to tackle this problem of 3 times 12, maybe I'll break it up a little bit differently even. So 3, and then I'm not going to bother with the 3 lines, but then with 12 is such a big challenge, I'm going to break it up into 10 and 2. So do we know what 3 groups of 10 is? Okay, that's 30. And then 3 groups of 2, that's 6, and then I can see 36. And this is really helpful because this is how you can really efficiently do mental math, right? So if I think of 12 times 30, a lot of times I think, okay, I have 3 groups of 10 and also 3 groups of 2. What does that amount to? Okay. Hopefully not awful. Let's try one that's even tougher. And I'm not going to break it up as much as I did earlier. I'm going to do more of this sort of style. So let's try a different number. Let's try 23 times 17. Seems pretty ambitious. All right, so I'm going to make it 23 this way, I guess, and 17 this way. And a way to break it up so that I can see it better is I'll let this be 10 and this be 7, and I will let this be 20 and this be 23. And now I can just do it piece by piece. So 20 groups of 10 would be 200. 20 groups of 7, that's 140. 10 groups of 3, that's 30. And 7 groups of 3, that is 21. Okay, so I can do the typical algebra alongside it, and hopefully we can see a little bit of a pattern. So 3 times 7 is 21. Carry the 2, so that's a 21 I got down here. And then 7 times 2 is 14, that's my 140, and I'm adding 2 to it. So I'm going to get 16. And that's what I would get if I added these two. So just to clarify, the product is going to be the sum of everything. I've got 200 over here, 140 over here, 30 over here, 21 over here. So I'm going to have to add all that up, and that's going to be what my product is. And product is just a result of multiplication. All right, continuing onward, I think we were taught to like put an X or draw a 0, because now we're on to the next place. And then 1 times 3 is 3. There's our 30 that came up from this box. And 2 and 1, there's our 200. This is actually where 200 in the place it's in, that came from this box. And we can add it up, 391, and that's what we would get if we tallied this up also. So that's what I want you guys to do in the discussion section. I will make a post titled Area Model for Multiplication. I want you guys to, if you want, you can do a simpler example to start out with, but what I definitely need to see in that post is a 2-digit number times a 2-digit number and represent it with the area model. And then if you would like to do this on the side too, that's great, but this is really what we're looking for in the discussion section. So again, discussion section titled Area Model for Multiplication will have to feature a multiplication of two 2-digit numbers, similar to this one. All right, thank you guys.